Hi, I'm Tom Tromey. I'm going to talk today about LLVM and Rust and debugging. I work at Mozilla, and I'd like to start my talk by saying thank you to Mozilla for backing Rust and also sending me to this conference. It's very nice of them. And I also wanted to tell you a little bit about myself. I used to work at Red Hat on GDB. I worked on GDB for a number of years. And then I moved to Mozilla and worked on other things. But I have a long sort of term interest in debugging. And I also really like Rust. I think Rust is what the programming world needs. So another nice thing that Mozilla has done is give me the opportunity to combine these two things I really like Rust. So give you a little overview of what we're going to learn about today. We're going to learn a little bit about Rust. And I mean a little bit. It's like one slide. It'll probably take me about 45 seconds at this rate of speech. I'm going to tell you about today's state of debugging in Rust. I'm going to tell you about my plan for how to fix debugging in Rust. My theory of debugging is that a great language deserves a great debugger. So that's what I hope to achieve. I'll tell you about the work in progress, things I'm working on right now, and maybe how you can help. And then I'll end with some commentary. And in yesterday's talk, I said, commentary, what it really means is I'm going to complain about other people's work. I'm going to tone down my complaints a little today. I felt a little weird yesterday. Okay, so who knows Rust? Yeah. Okay, so Rust, the system language for Mozilla. I feel like it fits in kind of the same general niche as C and C++. It has an emphasis on safety. Now, if you write Rust, like when I think about programming languages, there's kind of two views. I mean, there's a lot of ways to do it, but there's two that are interesting for the point of this talk. One is like the compiler. Right? When you write Rust, you're dealing with the compiler's view of the language. There's all these things in Rust that are different from C and C++. There's match statements, and all kinds of statements can yield a value. And there's lifetimes, and there's the bounds checker. Almost all that's invisible to the debugger. The debugger doesn't care. From the debugger's point of view, what's interesting about a language is like its type system. And then sometimes there are some auxiliary things that are interesting, like for instance in Rust it would be macros. Macros are something that maybe the debugger has to know a little bit extra about. But all that other stuff, is just not visible at all. And then there's a few things, I touched on this a little with my statement about macros. There's a few things in debugging Rust that I still don't really know what we should do. One is exactly how to treat macros. And another one is a kind of general problem in some of these more, I don't want to use the word modern, but like, in Rust, values have moved semantics by default. You see a lot of this in C++ as well now, right? People use R value references and move values. That presents a challenge to debuggers. Like, the question is when you're debugging and you want to call some function, if you're moving the value out, you're sort of destroying some state that the compiler has put into your program that's important. Another way to look at it is like if you're debugging in C++ and you create temporary objects, when do you call a destructor? Does the debugger call it? Should it call it? Because do otherwise innocuous things, print this variable, and then you trash your program state when you're so I don't really know how to solve that problem. Maybe you have some ideas. Maybe I didn't very express it. So, the state of things today. A while ago, a year or two, I wrote GDB support for Rust. I did the bulk of it. A guy named Manish who works at Mozilla, who's fantastic, did some of it. He did the hard part. I'm just taking credit for it. So GDB support works pretty well. Rust, so that's part of the state of things today. The other thing that is peculiar about today is Rust has its own fork of LLVM. Now, it's sort of complicated. The Rust compiler can be built against multiple versions of LLVM. But there's one sort of blessed one, which is the one that the official builds are built against. And this will, when I talk a little bit later about like what it takes to fix a debugging bug in the Rust compiler, this will come back and bite us. We'll see. Even with GDB, GDB support for Rust debugging, and GDB understands a lot of stuff about Rust types and that kind of thing. It has a Rust expression parser. There are still things that are missing. So, for instance, if you're debugging a Rust program, there are some kinds of unsized types that aren't represented well in the program. So there's no way to really inspect them unless you know how the Rust compiler happens to lay them out there. You could do that. I've done that. It's terrible to do it. There's also, like, traits are not in the debugging info at all. So you can't do anything that requires you to know anything about a trait. Like, so for instance, that move problem, the trait is copy, or I mean, if the type has the copy trait, you can just do that. However, there's no way to know if the type is the copy trait. And there are many other things like that. Like if you want to add operator overloading to GDB, well, you can't actually know which types implement those traits. You can't make trait method calls and things like that. Rust debug info currently is very, and sort of consciously, C++ like. Now, that doesn't mean a whole lot necessarily, because Dwarf is just Dwarf, and there's sort of, if you read Dwarf, usually there's just kind of one obvious way to represent something. It's not a big deal. But what happens is, the reason it's a little more C++-like than you might think is so that LLVM will have some hope of understanding what's going on. So, and this leads to like a logic. I want to, improve the debugging information for things. I want to add like debugging info for traits, or I want to do this or that. But you can't do it because LLVM won't understand it. So, and because LLVM thinks it's all C++ code. So we're stuck. So that brings us to the plan. So part one of the plan is to unblock this logjam by writing LLVM plugin. And that's in the works. I'll talk about some details about that in a few minutes. Then once LLVM is working, the idea is to improve all the tools in lockstep. So add a debugging feature to the Rust compiler, which might involve adding a debugging feature to LLVM, and then add support for that to GDB and support for it to LLVM. And then just sort of repeat. While we're at it, there's some bugs. Like there are a few bugs that I can just fix without, needing to have LLVM working. So I'm working on one of those as well right now. And then as we go through this list of all the things in Rust that don't quite work yet with debugger, we'll find that we need new things from Dwarf. And so my plan is to submit a bunch of extensions to Dwarf. There's already at least two, I think, in LLVM and in the Rust compiler that I haven't even filed with the Dwarf standard thing. I meant to block that. And then eventually, what I want to get to is a new rule for Rust, which is you can't add a feature without adding debuggers. Like, I think the way that I would want that to work is the compiler folks will do the compiler side, and someone probably will do the debugger side. But the idea would be, if you add a new Rust language feature, you have to plan for debug information at that moment and not leave it as an afterthought. We've already seen things where, like for instance, last year, there was a big patch series to add better compile time optimization of Rust email layout. You know, the like compress emails in cases where you can leave out some data, and that like broke a lot of the debugging from the debugging of those types that was already there, which was already a hack, but now it's a hack that can't even bust anymore. So remember back here I talked about like a slide ago, I talked about maybe the difficulties of Rust having its own LLVM fork. So I want to take you through the workflow that I do. Like for instance, this email problem I just mentioned, I've been working on a patch series to fix that. So the way this patch series looks is, well, to add enum support, it turns out you have to patch LLVM to add this thing called Dwarf tag called DW tag variant, which is like for variant types. It's a thing that was introduced for Pascal, but we can reuse it for Rust. And I don't have a problem with that. I think it's good to reuse things even if maybe they're not a perfect fit. Like my view is you have Rust, you have the expression of Rust in debug info, and then you have what the debuggers do. And I don't think that the tags all have to say Rust or be an exact fit, as long as that process is documented. Like somewhere we say, well, Rust compilers should do this. So, to add variants, LLVM doesn't ever generate variant parts in the debug info. So first we have to patch LLVM. Well, which LLVM do we patch? Another part of my philosophy is you want to test everything end to end and write all the patches before you try to submit it into patches. And the reason is you might miss some stuff. Like I don't trust my ability to sit down and just think it through in a pure plot sort of way. I'm not that smart. So we start by patching Rust LLVM. Okay, great. Takes a little while. Then you patch the Rust compiler to use this new stuff you added to LLVM. Okay, so now you can compile a Rust program and read the dwarf, and it looks right. So then patch GDB, because GDB and LLDB also never dealt with variant parts. Those are just completely ignored by GDB's dwarf reader and also LLDBs. So patch GDB. And the reason I patch GDB is, the LLDB plugin's not done, and I don't want to add some weird feature to LLDB C++ support that isn't in C++ feature. It doesn't make any sense. So I patch GDB. Now it all works. And what for this particular patch is kind of depressing, because what it all works means is it works exactly the same as it did a year ago before the compiler changed plans. So it does nothing, apparently. So that's all great. It's time to submit our patches. So what do you have to do? Well, first you have to port your Rust patches to the LLVM trunk. Rust LLVM doesn't really take pull requests. Like they don't encourage, say, development of LLVM off on some fork. It's more like a stability thing with a few Rust tweaks. So they'll accept a patch, but they want it to go into LLVM trunk first to preserve their ability to upgrade LLVM version. I don't know. Makes perfect sense. Of course, LLVM changes all the time. It's a huge project. As far as I can tell, it's like just anything goes. We'll just change it all. So you have to forward port your patches from Rust LLVM to the LLVM trunk, and then you have to go through patch review. So this patch went through 4 rounds of patch review, which isn't too bad, honestly. Once in GDB, I saw 17 rounds. It was about, how many rounds too many is that? 7, 11? Anyway, patch review pointed out that way back at the beginning, I misread the dwarf standard and did everything wrong. Yeah, and this is a story I told yesterday about, sort of this area. It turns out that everyone else, except for this one LLVM reviewer. Everyone else who ever read that part of the Dwarf standard also interpreted it the same incorrect way that I did. So, something's going on there. Anyway, I did it all wrong. So I fix up LLVM. Then it lands, But now I get to go back to the beginning and start over. Okay? Like I have to backport, Here I forward ported. Now I fixed a bunch of problems. Now I backported, and then I fixed up the Rust compiler. And then because I did the dwarf wrong, I have to fix up GDB. And I think if I was being truly meticulous, like in this case, I think it's, I have a pretty good handle on it. I feel like it works. The change was not too big. But if it was a hairier problem, right here before landing, I would go back and do it up again, right? To make sure that it was working. This one I cheated a little, and so all I have to do is backward and redo Rust and redo GDB once. So that's what the workflow looks like.
How much work does it
I feel like, well, I do multiple things in parallel, so it's hard to say, but the elapsed time is maybe 2 months. Or I consider this one of the smaller projects. Like, this is one where I really thought, I can just whip this out and, couldn't do that. So, and we'll talk about this. We'll revisit this stuff a little bit later in the commentary section. Okay, so now, I'm going to talk a little bit about LLVM. So I'm writing the Rust plugin for LLVM. It's here. You can go see it. I would say it's about halfway done. So I wrote, LLVM internals. Okay. There's this thing, Rust AST context, and there's Rust language. These are 2 classes you have to implement if you're, or like 2 files, modules that you have to implement if you're writing a plugin. Those are pretty much done. I wrote each language in LLVM is kind of responsible for some of its own dwarf interpretation. Like LLVM does all the mechanics of reading the dwarf, but it sort of hands them off to your language to make sense of. What is this type? What does it mean to you? And then your code figures out what it means and talks to your AST This is sort of a nice design. GDB does it in basically the complete opposite way, but both designs have interesting properties about them. This one, the interesting property is you don't have to know anything about any other language except your own. Right? You control everything, the representations, and you look at the dies and decide what they mean. In GDB, there's like one thing that decides everything, and so in GDB sometimes you'll be touching something and you'll say, well, I could do this here, but I don't know Ada. I'm scared to break Ada code. Right? But on the other hand, the downside of the LLVM approach is that you have to be, every person who writes one of these languages has to be a super expert on Dwarf, because you have to know all the different rules that you are responsible for interpretation. Whereas in GDB, those decisions are centralized. So in GDB, like if a new Dwarf feature comes along, it's added once, whereas in LLVM, maybe it has to be added to every language separately. Or maybe some of them will lag and some won't. So it's an interesting set of trade-offs. I don't know. Anyway. So all the dwarf reading stuff is done. It seems to work all right. I have like some tests in the tree. I wouldn't actually use it in real life yet because expression parsing is done. And expression parsing, there's not a name for it here, but basically, LLVM also will, if you type in, some expression, print this thing, it will hand that expression to your language plugin to parse and understand. And so I haven't done that yet. I've talked with other people in the Rust community. How should we do it? Now in GDB, there's a very straightforward way to do it, which is you write a parser. That's how everything in GDB works. And it has one nice quality, which is GDB is like self-contained, but it has some other downsides in terms of, you know, adherence to language standards, maintenance issues, you know, like GDB has, you know, Modula 2 parser that hasn't been touched in 15 years, doesn't work. Does anyone know Modula 2? So, so one idea that we had is, in Rust, you know, like one obvious idea in the LLVM context is just reuse the compiler. The compiler guys are like, no. So, I guess the compiler has this, you know, module, a crate, that's the Rust word for module. The compiler has a crate, the syntax crate, which is maybe not the best one to reuse. That's what I understand. I've never looked at it. But there's this other one called Syn, which is a Rust, it's like a Rust language parser written in Rust, and you can just drop it in and use it. So, you know, our idea was, well, let's just reuse this existing Rust program, you know. Maybe we can write a library, have LLVM DLL in the library, just call into it to do the parsing, or maybe we can write the current thing I'm looking at is maybe I can write it as an external process, you know, and talk to it with like types. Type in the data and get back, you know, something. LLVM has this, somewhere in like the utilities is this thing to do like YAML parsing and write into C++ objects or something like that. And I thought, well, that sounds cheap, you know, like put that together, you know, things software. So, but then, you know, so we can do that. I'll probably do that. But then, how are we going to ship this thing, right? Like, if it's a library, you know, it doesn't really matter. It's a library, it's an executable. Like, if we wanted to have it in tree, you know, that would be like a Rust compiler dependency for LLVM, which I think would be, you know, really bonkers. We could ship it with Rustup. You know about Rustup. Rustup is like a Rust toolchain manager. You use it to install your toolchain. So one idea would be another artifact. So you Rustup install and you get the LLVM plug in, you know, and it would just depend on the same crate. That would work, but then that makes testing in LLVM very weird, right? Well, so I don't know. I don't feel like we have an adequate solution. But we'll come back to that too in the discussion part at the end, because you know, maybe we don't need a solution to that problem. There might be a different problem. Okay, so now I'm going to talk a little bit about Dwarf. We need Dwarf extensions. You know, we already have some. We cheated on this thing for how we emit virtual tables. You know, like I was talking about this a lot yesterday. C++ debuggers like or C++ compilers don't emit stuff about virtual tables into Dwarf at all. It's just completely not represented in the debug info. There's a side channel, right? The debugger also knows about the ABI and crawls around the ABI to find these things. And in Rust that didn't work. Rust doesn't have a stable ABI. Not yet. You know, maybe not ever. I don't really have any idea. But it doesn't have one. And so our idea was, well, we'll write information about vtables for this thing called trait objects into the debug info. So doing that nicely required a Dwarf extension. And I was also talking about this yesterday. That Dwarf extension is currently documented in a comment in LLVM. Yeah, I know. I'm trying to find that. It's a great comment. And we're going to need some extensions for like aspects of the Rust type system that don't quite match up to other existing things. Like, so for instance, Rust has two kinds of structure types, and it's nice to differentiate them somehow. And the Dwarf way is to differentiate them explicitly, right? Like have a different tag for the different kinds. So, you know, I'm going to have to file some Dwarf plugs. and I was talking about this yesterday as well, but it bears repeating. I think Dwarf is the logical place to collaborate on improving debugging. It's the centerpiece, right? The compilers talk it, the debuggers talk it, and because I'm working on LLVM and also GDB and LLVB, it's like a cross-tool chain thing. So, like with this enum thing, and discovering during review that I had done it wrong, like I had to talk to Ada people about their issue because Ada can admit that, and talk to LLVB people or LLVM people about the interpretation of the standard. And the best place to really do this would be the Dwarf standard. However, the Dwarf standard is currently run in a very closed way. Pierre-Marie from Ada Core submitted a bug, against the Dwarf standard for this thing that we were talking about with variant types, and it took 3 weeks for the bug to even appear on the website. And once a bug appears, there's no way to comment on it. Like I can't go and say, this bug came from here, and I want to do this, and I think this is more logical. It's just not possible. There's no way to do that. Maybe I could join the committee. I don't know. So I want to somehow, get everyone to agree that we should try to open for. I don't know how to do it really, but I think it could be more open. So if you're on the Dwarf committee or someone you work with, you should give them a little push. Okay, so now we've all been waiting for the commentary part. This workflow sucks. It's terrible to do all this stuff like 2 times or maybe 3 for a complicated patch. It's just not good. I don't really know what to do about it. One idea would be maybe Rust could somehow track LLVM a little more closely so that the backports are less good. But I think that's complicated as well, right? Because of LLVM's sort of rapid rate of churn, I think it's pretty difficult to to move Rust from one version to another. I don't actually know the details about that, but I feel like they're still stuck on 4. Whatever it is, for a reason. There's something blocking the upgrade. And I know that when people have tried upgrades, there's been regressions and stuff. So there's usually like a tail, right? Like they do the initial upgrade and do a lot of testing, and then there's a bunch of bugs that have to be fixed first before they can really commit to. So that's one thing. That's my wish list. Better workflow for me. Another thing is with LLVB. So LLVB has a plugin architecture. You can write these plugins that are separate shared libraries that get loaded by LLVB. Except you can't do that for a new language. There's no way to write a language as a plugin. And the reason is there's kind of 2 reasons. One is there are these Dwarf reader header files that don't get installed. But also I think there's a stability issue where LLVB only wants you to depend on a certain set of APIs, and this would require a much bigger API service, and they don't want to commit to it. But if we could do it externally, we totally would, right? That would be the easiest deployment situation for us. It would exactly parallel the deployment situation for how Rust uses LLVM, right? You get some version of LLVM and you can build Rust against it. Well, it would be the same. You get some version of LLVB and you build our plugin against it. But we can't do that. So that's what got us into that deployment problem I was talking about. How do we deploy the parser? How do we deploy LLVB? And then recently there's been some talk on the LLVB list of, well, maybe we don't even want to land new languages till they're proven in some way, which I don't know what, it was a little vague for me, so I don't really know what the way is. But what that said to me is maybe instead of figuring out how to deploy my plugin or how to deploy my little helper thing to do Rust language parsing, I'm just going to have a fork of LLVB for some period of time who knows how long, and figure out how to deploy that. I'm not too happy about that. I don't really know what to do about it other than, you know, I think for me, this is the most promising one, but I don't know. Then, just generally when I work on LLVM, you know, I think you could use more documentation. There's a little bit, there is a web page about how to write a new language plugin, but it's very thin. And there aren't many comments in the source, so I ended up like reading through the other language plugins and sort of trying to figure out what the heck they're doing and write mine based on theirs. But that's like, that's a dangerous way to go. And the reason is you don't really know. Am I copying a good one or a crazy one, right? Like, maybe the quality varies a lot. And of course, you know, you can do the flagship, right? Like, go see what C++ does. But it's so complicated, right? Because it's like the most fully featured one. So it has a lot of depth to it. And there's a lot of things in there where you think, I don't even know if this is something I need to worry about or some weird corner case. So it's very nebulous, right? Like, it would be nice to have just a little more of a guide. Like one idea would be to have a sample language plugin, a skeleton that says do this or do that. That would be the ideal. Now, of course, you know, I say that I'm probably not going to do it, even though maybe now I'm well situated to do it, having learned all that stuff. So, that's the classic. Okay, that's actually the end. So, are there any questions? Yeah, go ahead.
We are talking about Dwarf, so this is all Unix. What about Windows?
Okay, very good. So the question is, this is all Dwarf and it's Unix-centric, and what about Windows Debugging? So LLVM can generate PDBs. You know, Microsoft tried to help out. They published, there's this thing on GitHub, which is their documentation for their debug format. Documentation consists of a code drop, which I would describe as classic Microsoft code. So there are people skilled in reading that. I'm not one of them. So yes, I would like to. You know, I think it would be good if we could use things that I changed in LLVM if they were hooked up properly to PDB. I don't know how to do that. And I don't even really know who to ask. So that remains, you know, question. All right. Yeah, what's up?
Can you tell me something about Rust philosophy? Why they want to do a evaluation and linking with one code? Just optimizations of philosophy.
The Rust philosophy of like compiling and linking.
Linking one code.
Yeah. You know, currently Rust is currently Rust doesn't really have great support for like making shared objects. You know, it's pretty much just static linking. I don't know that I can answer that question other than that. Like, I don't know what the philosophy is or why it's that way. So, yeah, sorry about that.
So you're speaking about both LLVM and GDB, so what's used for debugging, Rust,
Right. Okay, so the question is, what do people use for debugging Rust? Do they use LLVM or GDB? People use both. Yeah. It's just if you use LLVM right now, you have to pretend that it's C++, and there's some things that don't work.
So you want to fix both?
Yeah, I want to fix both. And GDB, that work is further ahead, primarily because I knew GDB well enough to just write it, whereas LLVM, you know, like, I had to learn more, so it took time. But, yeah, so, and in fact, actually in LLVM, there is those lines somewhere in there where it's like, if you're reading the Dwarf and you see a Rust language tag, you just route it over to the C++ plugin. So even if we like you know, land all this stuff separately or somehow get a plugin or whatever. There's still one patch that's going to have to go in to like keep that running. You know? Yeah. Any other questions? Yeah.
So you said that the web browser will not use Rusty commands,
Right.
but for PP we do use them.
Yeah.
It's probably a story that I do because on average we have to produce a new version of PP more than once a week.
Right.
Because it breaks all the time. But we are going to improve that by shipping PP and just
Okay.
Why do we want that? Because
Yeah.
if you use the sync rate rather than the syntax rate and date rate,
Yeah.
you don't have type information. But I guess you would like to have that as well.
Yeah.
The sync rate does less.
Right. So, okay, so the question is, why aren't we using the Rust compiler? Because Clippy, which is this sort of linter type thing for Rust, does use it. And he pointed out that like the Rust compiler would have like type information, whereas syncrate is just a parser and doesn't really know it, you know, very much. Yeah, you know, I just talked to I talked to some of the compiler guys. I talked to Nico. He just said, and I shouldn't put words in his mouth because it's my understanding of what he said, and I could just be blowing. But my impression is his opinion was that the syntax library just wasn't really reusable, and they were hoping to do massive changes to it or something, and it's better not to depend on it. And then as for the type thing, you know, so there's a certain weirdness to doing these things in debuggers. Debuggers have access to the types, but they have access to like some transmuted form of the types, right? So, you know, you could go either way. You could use the whole compiler, but then require the source to be around and sort of ignore the dwarf. Swift did something like that. They actually serialized their IR in these files. Maybe that's doable. I'm looking to do something a little, at least in the short term, to like get things off the ground, something a little simpler. And so Syn, for me, it's like it can handle the parsing of like Rust expressions and dealing with what do the names mean and what are the types is something the debugger already knows from reading work. And so I thought it was a decent trade-off. It may not be the best one, you know, like I'm not actually sure. But one thing I was thinking is just to get something working so we can, like I was saying earlier, remove that logjam and start moving things forward. And then, you know, we can revisit any decision later, like, oh, we want something better, we can change it. We'll have the freedom to do that at that point. Yeah. Yeah.
Can you evaluate complex Rust expression with a debugger that P space?
I'm sorry, I couldn't quite hear you.
Can you evaluate complex Rust expressions
Complex Rust expression?
in the debugger?
Yeah, that's the goal. So like in GDB you can use like, you know, because Rust is like this expression language, there, you know, this difference between statements and expressions is a little, you know, not sharp, right? Like match, technically an expression. GDB doesn't implement match. You know, it implements sort of this C-like subset of expression. But yeah, like GDB understands Rust syntax pretty well. You know, you can use slices, you can, you know, you examine tuples using dot zero as opposed to some other thing. And, you know, does that answer your question? So
Yeah, so I guess for more complex stuff, you need the compiler to type inference for it.
well, so yes, type inference can be a problem, and so can, all right, my time's up, but let me finish. Type inference can be a problem, and so can, you know, like I was talking about the semantics, and, or like operator overloading can't be done with trace not being represented. So, you know, it's like a bootstrapping problem. We have to do something to unbreak the logjam so we can make the debugging flow better, so that we can make the expression parsing better, you know, so that we can advance to the next level.